As scientists, we are trained to follow the evidence wherever it leads, even when it challenges our most cherished assumptions. This principle, simple as it sounds, becomes remarkably difficult to uphold when the data points toward conclusions that unsettle our comfortable paradigms. In July of this year, astronomers detected what initially appeared to be an unremarkable speck of light against the cosmic background. We cataloged it as 3I Atlas, designating it the third known interstellar object to pass through our solar system. The first two, 1I Oumuamua in 2017 and 2I Borisov in 2019, had already demonstrated that our solar system receives visitors from interstellar space more frequently than we previously imagined. But 3I Atlas has presented us with observations that demand we ask uncomfortable questions about the nature of what we are witnessing. Let me be clear about what the data shows. This object is moving at approximately 152,000 miles per hour, roughly 5 times faster than typical asteroids or comets within our solar system, which travel at velocities around 20,000 to 30,000 miles per hour. When we traced its trajectory backward through space, the calculations revealed something significant. This object did not originate from our asteroid belt, nor from the Kuiper belt, nor even from the distant Oort cloud. Its path leads back to the space between the stars, suggesting it has been traveling through the galaxy for tens of thousands of years, perhaps considerably longer, before intersecting with our solar neighborhood. These are observable facts, not speculation. For several months after its discovery, the astronomical community approached 3I/ATLAS with measured interest. We had precedent for interstellar visitors. We observed, we measured, we calculated its trajectory with the precision our instruments allow. The object moved through our solar system as expected for a body following gravitational mechanics. Then something unusual occurred. Radio telescopes at multiple locations on Earth operating independently detected what appeared to be a focused signal emanating from the direction of 3I/ATLAS. This was not the random noise of cosmic radiation or interference from our own technology. Multiple detection stations, separated by thousands of kilometers, registered the same phenomenon simultaneously. The signal possessed characteristics suggesting deliberate structure rather than natural emission. Now, we must be cautious here. Extraordinary claims require extraordinary evidence, as Carl Sagan wisely noted. Could this signal have originated from some atmospheric distortion? Could solar activity have produced an artifact in our instruments? These are questions we must ask, but we must also acknowledge what we observed. The signal appeared once with sufficient clarity and coherence to be recorded by multiple independent systems. If it was instrumental error, it was a remarkably synchronized error across geographically dispersed equipment. The scientific method compels us to investigate further rather than dismiss observations that don't fit our expectations. What makes 3I/ATLAS particularly intriguing is not any single anomaly, but the accumulation of unusual characteristics. Consider its luminosity. When we study celestial bodies, we determine their properties by analyzing how they reflect sunlight. Natural space rocks, sculpted by billions of years of cosmic impacts and radiation, possess irregular pockmarked surfaces. These rough textures scatter light in diffuse patterns, producing the dull, inconsistent brightness we expect from asteroids and comets. Yet 3I/ATLAS reflects light with unusual uniformity. Observations from the James Webb Space Telescope revealed that photons bounce off its surface with a smoothness suggesting either an extremely unusual composition or a remarkably uniform structure. This is not impossible in nature, but it is statistically improbable. Then we encounter the rotation data. Natural celestial objects tumble through space erratically. Their rotations are chaotic, influenced by countless past collisions and gravitational interactions. We expect wobbling, irregular spin rates, and unpredictable orientations. Yet, 3I Atlas rotates with notable stability. Its luminosity variations follow predictable patterns with minimal deviation. The object maintains specific orientations relative to our observation points with what appears to be mathematical regularity. Again, this is not impossible for a natural object, but it represents an outlier in the statistical distribution of behaviors we have documented from thousands of observed bodies. The thermal data raises additional questions. When Webb's infrared sensors examined 3I Atlas, researchers anticipated the standard thermal profile, shifting patterns of warmth and cold as different surfaces rotate through sunlight and shadow. Instead, they observed a persistent temperature differential between one side and the other. One possible explanation is that the object is generating heat internally, though no natural comet in our extensive catalog has demonstrated this capability. Another explanation is that the object possesses some form of thermal distribution mechanism. Neither explanation fits comfortably within our current models. The spectroscopic analysis yielded perhaps the most puzzling results. Where we would normally detect abundant water vapor sublimating from a comet as it approaches the sun, 3I/ATLAS releases carbon dioxide at levels 10 times higher than expected. More striking are the metallic signatures. The object emits extraordinary quantities of nickel while showing minimal iron content. This inverts the typical pattern we observe in cometary and asteroidal bodies throughout our solar system. The carbon-based molecules detected in its emissions display a complexity we do not usually associate with the random chemistry of deep space. These molecules show organized structures more reminiscent of either biological processes or deliberate synthesis. Density measurements add another layer to the mystery. The data suggests that 3I/ATLAS is not a solid monolithic body. Instead, it appears to contain internal voids, empty spaces within its structure. In nature, celestial bodies form through gradual accretion. Particles accumulate, compress under gravity, and create dense, solid structures. Hollow regions typically do not survive this process, yet the resonance data from 3I/ATLAS indicates significant internal emptiness, as though its architecture was constructed rather than accreted. Most remarkably, 3I/ATLAS is changing its trajectory in ways that cannot be fully explained by gravitational forces alone. We observed similar behavior with Oumuamua, which exhibited what we called non-gravitational acceleration. The conventional explanation invoked outgassing, the ejection of sublimating volatiles that would act as a natural propulsion system. But for this mechanism to work, we should detect the corresponding gas emissions. With 3I/ATLAS, the trajectory corrections occur without the expected outgassing signatures. The object adjusts its path through space as though guided by forces we have not yet identified. These observations, taken individually, might each have mundane explanations. Unusual chemistry could account for the spectroscopic anomalies. A fortuitous collision history might explain the regular rotation. The thermal signature could result from subsurface composition we haven't considered. But when we examine these characteristics collectively, we face a question that makes many of my colleagues uncomfortable. At what point does the accumulation of statistical improbabilities require us to seriously consider hypotheses we have traditionally dismissed? In science, we rely on Occam's razor, the principle that the simplest explanation is usually correct, but we must be careful not to confuse simplest with most comfortable. If I present you with a set of observations that, when taken together, are inconsistent with natural formation processes but consistent with artificial construction, which explanation is actually simpler? The one that requires inventing multiple new natural phenomena to account for each anomaly separately, or the one that proposes a single explanation that accounts for all observations simultaneously? This is not to say that 3I/ATLAS is definitely artificial. I am not making that claim. What I am saying is that the possibility deserves serious scientific investigation rather than reflexive dismissal. We have a responsibility to examine the evidence objectively without allowing our preconceptions about what we expect to find color our interpretation of what we actually observe. Here is where the situation becomes more concerning from a scientific perspective. In recent months, there has been a notable reduction in publicly available data regarding 3I/ATLAS. Initial observations showing its unusual velocity and brightness were released without delay, but as more sophisticated analyses began revealing the anomalies I have described, the flow of information slowed significantly. We have seen this pattern before. When observations challenge established paradigms, there is often institutional resistance to public disclosure, whether from concerns about premature conclusions or perhaps from uncertainty about how to interpret unsettling data. The phrase national security has been invoked in some contexts regarding 3I/ATLAS observations. This raises a question. What aspect of a comet passing through space could possibly constitute a security concern? The timing of this information restriction, coinciding precisely with the discovery of the object's most unusual characteristics, suggests that decision makers at certain agencies may have encountered something they consider significant enough to limit public discussion. We face two possibilities here, neither particularly comforting. Either governmental agencies have uncovered evidence suggesting something genuinely anomalous, something they believe the public is not prepared to confront, or they are examining data they cannot adequately explain and have chosen caution over transparency. In either case, the restriction of scientific data for non-scientific reasons represents a troubling precedent. Science advances through open investigation and peer review, not through classified briefings and limited access. Let me return to that radio signal. If the detection was genuine and we currently lack definitive proof that it was instrumental error, then we must acknowledge what this implies. The object possesses, or possessed, the capacity to transmit electromagnetic radiation in a structured way. This goes beyond passive reflection of sunlight or random emission of thermal radiation. It suggests active communication, though we do not know the intended recipient or the message content. This brings me to a hypothesis that some find uncomfortable, but that deserves consideration. Imagine an advanced technological civilization monitoring the development of intelligence elsewhere in the galaxy. For thousands of years, humanity lacked the technology to detect objects passing through interstellar space. We were effectively blind to visitors, but in the past decade, our observational capabilities have improved dramatically. We can now detect, track, and analyze these objects with unprecedented precision. If you were an advanced civilization interested in assessing emerging intelligences, when would you initiate contact? Perhaps precisely at the moment when the observed species demonstrates the capability to notice you. Notice the pattern across the three known interstellar visitors. Oumuamua presented us with unexplained acceleration. 2I/Borisov, while more comet-like, still carried unusual chemical signatures. Now 3I/ATLAS arrives with its accumulation of anomalies, each pushing slightly further against the boundaries of natural explanation. Each object has been progressively more unusual, more challenging to our existing models. If these were probes, would we not expect precisely this kind of graduated introduction? Not so overwhelming as to cause panic, but sufficiently unusual to stimulate serious investigation and force us to question our assumptions? I want to emphasize that this remains a hypothesis, not a conclusion. Natural explanations certainly exist. We may be encountering exotic chemistry or physical processes that interstellar space produces, but that our current models, based primarily on solar system observations, have not yet incorporated. The universe is vast and full of phenomena we have not yet cataloged, but the scientific method requires that we consider all hypotheses that fit the data, including those that challenge our worldview. The question we must ask ourselves is this: are we willing to follow the evidence wherever it leads, even if it leads to conclusions that seem improbable based on our prior expectations? Or will we, like scientists in previous eras who rejected evidence of continental drift, heliocentric solar systems, or quantum mechanics because these ideas seemed absurd, allow our biases to prevent us from seeing what the data is showing us? I have spent my career arguing for a simple principle. We should approach the search for extraterrestrial intelligence the same way we approach any other scientific question, with rigorous methodology, empirical evidence, and an open mind. When we search for biosignatures on exoplanets, we look for atmospheric compositions that suggest biological processes. When we search for technosignatures, evidence of technological civilizations, we should apply the same standards. If an object's characteristics are more consistent with artificial construction than natural formation, we should investigate that possibility seriously rather than dismissing it out of hand simply because it makes us uncomfortable. The scientific establishment has historically been reluctant to engage with questions about extraterrestrial intelligence in a rigorous way. This reluctance stems, I believe, from a fear of being associated with fringe speculation. But this fear has created a paradox. By refusing to apply serious scientific methodology to these questions, we ensure that the field remains speculative. The solution is not to avoid the questions, but to approach them with the same rigor we apply to any other scientific investigation. 3I/ATLAS represents an opportunity. Whether it ultimately proves to be an exotic natural object or something else entirely, it has already served a valuable purpose. It has forced us to examine our assumptions about what is possible. It has revealed gaps in our understanding of interstellar objects and the processes that form them. It has demonstrated that our solar system is not isolated but regularly receives visitors from the galaxy at large. These lessons alone justify serious, sustained investigation. As 3I/ATLAS continues its journey through our solar system, we have both a responsibility and an opportunity. We must demand transparency in the data. Scientific progress depends on open access to observations and the ability of independent researchers to analyze and verify results. We must subject every measurement to rigorous scrutiny, seeking natural explanations before entertaining more exotic hypotheses, but not dismissing those exotic hypotheses simply because they challenge conventional thinking. The universe has shown us repeatedly that it is stranger than we imagine, from quantum mechanics to black holes, from dark matter to the accelerating expansion of space itself. Nature has consistently revealed phenomena that seemed impossible before we observed them. We should approach 3I/ATLAS with the same intellectual humility. We do not yet know what it is. The data is incomplete, and many of the most intriguing observations require independent confirmation, but we know enough to recognize that this object does not fit neatly into our existing categories. In my view, the most unscientific position we could take would be to decide in advance what the answer must be and then interpret all data to fit that predetermined conclusion. If we approach 3I/ATLAS with the assumption that it must be a natural object because artificial objects from other civilizations are too improbable to consider, we are not doing science. We are defending a worldview. Science requires that we remain open to all possibilities, that the evidence supports, weighting each hypothesis by how well it explains the full range of observations. There is something profound happening here beyond the specific question of what 3I/ATLAS is. We are living through a period when humanity's relationship with the cosmos is fundamentally changing. For the first time in our history, we possess the technology to detect, analyze, and potentially recognize evidence of intelligence beyond Earth. This is not science fiction. This is the present reality of 21st century astronomy. The question is not whether we will encounter such evidence, but whether we will recognize it when we do. I think often about how future generations will look back on this era. They will have access to more data, better instruments, and perhaps answers to questions we are only now beginning to formulate. They will judge us not by whether we got everything right, but by whether we approach the unknown with intellectual honesty and courage. Did we follow the evidence? Did we ask the hard questions? Did we allow ourselves to consider possibilities that challenged our assumptions? Or did we, like so many scientists throughout history, allow our preconceptions to blind us to what was in front of us? 3I/ATLAS is still there, moving through space, carrying its mysteries with it. Radio telescopes continue to monitor it. Optical and infrared observations continue to accumulate data. Perhaps in the coming months or years, we will develop a complete natural explanation for all of its unusual characteristics. That would be a legitimate scientific outcome, one that would expand our understanding of interstellar objects and the processes that shape them. But perhaps instead, the evidence will continue to accumulate in a direction that points toward a more extraordinary conclusion. In that case, we will face a choice about how we respond. What strikes me most about 3I/ATLAS is not any single anomaly, but the way it forces us to confront the limitations of our current understanding. We thought we knew what interstellar objects should look like, how they should behave, what they should be made of, and then the universe presented us with something that doesn't quite fit. This is how science advances, not through the comfortable confirmation of existing theories, but through anomalies that force us to expand our frameworks. The truth, whatever it is, exists independently of our beliefs about it. 3I/ATLAS is what it is, regardless of whether we find that answer reassuring or unsettling. Our task as scientists is not to defend our existing paradigms, but to understand reality as it actually is. This requires a particular kind of courage, the courage to examine evidence that might overturn everything we thought we knew. It requires humility, the recognition that the universe is under no obligation to match our expectations, and it requires persistence, the willingness to keep investigating even when the answers remain elusive. We stand at a unique moment in human history. Our technology has reached a level where we can genuinely search for evidence of intelligence beyond Earth, not through speculation or wishful thinking, but through rigorous scientific investigation. Objects like 3I/ATLAS, whatever they ultimately prove to be, represent the frontiers of this search. They are the test cases that will determine whether we are truly ready to face the implications of not being alone in the universe, or whether we will retreat into comfortable assumptions rather than confront unsettling possibilities. I do not know what 3I/ATLAS is. I do not know whether the radio signal was real or an artifact. I do not know whether its unusual characteristics will ultimately be explained by exotic natural processes or whether they will point toward something else entirely. What I do know is that these questions deserve serious, sustained, rigorous scientific investigation. They deserve transparency, open data, and the full engagement of the scientific community. And they deserve to be approached without the baggage of preconceived conclusions, following the evidence wherever it leads. The universe is speaking to us through objects like 3I/ATLAS. Whether that communication is the random language of natural processes or something more deliberate, we owe it to ourselves and to future generations to listen carefully and to think deeply about what we are observing. This is what it means to be a scientist in the 21st century, to stand at the boundary between the known and the unknown, armed with instruments that can peer into the cosmos with unprecedented clarity, and to have the courage to see what is actually there rather than what we expect to see. 3I/ATLAS continues its journey. The data continues to accumulate, the questions continue to multiply, and we continue to watch, to measure, to analyze, and to wonder. That wondering, grounded in evidence and methodology rather than speculation, is the essence of scientific inquiry. Whatever answers emerge in the coming months and years, the process of seeking those answers with intellectual honesty and rigor is itself valuable, because in the end, that is how we expand human knowledge, not by defending what we already believe, but by fearlessly pursuing what we do not yet understand.